Hi all, my name is Catherine Cronister, and today I'll be talking to you about NCAA retention rates, the transfer plague. Why should you care, and what is a retention rate? Well, a retention rate is defined as a number of student athletes who stay at an institution after their first year. In recent years, however, transfer rates, which is how many student athletes leave an institution at any point in their career, have increased dramatically. The NCAA actually estimates that 13% of student athletes leave an institution before the end of their sophomore year. As a current and former Division I student athlete, this was a really important problem to me, as I had many friends who transferred or considered transferring from their undergraduate institution. I believe these transfer rates have something to do with the sport one plays. For example, maybe a basketball player is a little more likely to transfer or not stay after their freshman year because they can go play professional basketball, and the academic rigor of an institution. If a student athlete shows up at a school that academically they're not a good fit for, it's going to be really hard for them to stay. So I wanted to ask, can we predict retention rate? And more importantly, I really wanted to see if there was any sort of insight a model could give me on these retention rates and maybe why transfer rates are increasing, just any information I could get. The data for this project included about 6,500 rows, and it had school type, so was it a private or a public institution? It had the sport, so volleyball, basketball, soccer. It had the NCAA division, so 1, 2, or 3. It had subdivision, which actually most schools didn't have. And then it had conference, so WCC, like that's the conference the University of San Francisco is in, or the Pac-12. And then it had four-year eligibility, which is an average from 2010 to 2014 in what percentage of student athletes in that sport stayed eligible. And eligibility in the NCAA really comes down to, are they staying on top of their schoolwork so that their school meets the level of standards that the NCAA sets. And finally, a four-year retention rate, which, as we mentioned on the last slide, is just the percentage of students averaged between 2010 and 2014 that stay at the school after their freshman year. A couple other interesting things about this data set are actually that -99 was used for missing values. So when I did a first pass for EDA, I didn't notice this. Luckily, I did some visualizations and I saw, as you can see in this image here, that there was this weird negative number hanging around that was really messing with my distribution. And that was personally just a great reminder of the importance of visualizations in data science and EDA when you start a project. I also want to mention that the data originally contained a score column. However, I removed it to make sure there was no data leakage because retention rate is actually used to calculate the score. To start with my model choice, I took about 5 or 6 different algorithms and simply tested them out on the data without any hyperparameter tuning. And I found that linear regression and random forest regressors had the lowest MAE and MSE. So I decided to pick those two and do some hyperparameter tuning. And I actually found that the linear regression outperformed the random forest regressor, excuse me, with hyperparameter tuning. For me, this was a great reminder of the no free lunch theorem, which is basically telling us that on average, one algorithm does just as well as any other algorithm on data sets. The final model I chose was a linear regression model that had an MAE of about 0.014 on the test set. What's really great about MAE in this case, because our data for the retention rate ranges from 0 to 1, is we can look at it as a percentage. So it was about 1% off on average, which is a very strong model considering the very few features we used to fit. And we did have a really large sample of data, so I think that was really helpful. Although prediction was important for this model, what I was really interested in was actually feature importance, any sort of interpretation of this model I could get. So I did permutation importance on our final linear model, and I found that sport code and eligibility were the most important features in predicting retention rates. What this tells me is my a priori notations of sport and academic rigor being important were correct. So maybe that it is true that basketball players are more likely to have lower retention rates because they can go professionally, or student athletes who attend a school freshman year that's just too tough for them are more likely to leave. And eligibility is really, again, about how are student athletes able to stay on top of school while playing a sport at the same time. From here, I really wanted to push my limits and try something outside of the scope of this class. So I created a deployment script that if you pass in some data, it actually gives you back a prediction in HTML file. So as we can see here, if we run the script out of the command line, passing in a text file that has the data we want predicted as an argument on the command line, we get a nice HTML file out of it, which gives us our predicted retention rate and actually kind of gives us a score as well. So I labeled good retention as above 0.9, great retention as above 0.9, good retention as between 0.7 and 0.9, and poor retention is anything less than 0.7, because really losing 30% of your student athletes after their freshman year is not a very good metric. In conclusion, there are really many reasons a student athlete may transfer. However, the sport they play really does seem to be a key indicator of retention rates. Again, I truly believe this is because of sports like basketball where they have that option to go pro. I also believe that this is a really big indicator that NCAA should look into these big money sports to see if there can be any changes made in the recruiting process so retention rates in these sports increase. What I mean is many student athletes focus so much on their sport and less about their institution as a whole that I think this could be a big change for the NCAA. Finally, I think, again, this really gives the NCAA a place to start looking. And with more information, such as previous wins or academic rating of the institution, we could further improve this model. Thank you for your time and have a great day.